Alright, so in my, if anyone even saw my previous video, that was really bad. Because first of all, I found two things. One, I found out that my the source code that I actually used to as a reference is folly. I checked on some references, and actually, what it turns out that the source code that I used for the reference actually lets some few test cases where it has a loop, and yeah, and then it still prints it. But this one is actually a bit more consistent. Now the last thing I want to add, after I search up in Google a bit about this thing, or any kind of like browser, I search on the net, and turns out there's one process I actually miss. It's what happens when you have parallel nodes, parallel edges. Parallel edges are essentially when you have a source and a destination, either with two or more edges. That's a parallel edges, and that must be removed. Or you have edges that returns back that goes from the same source from the source to the destination to its own, to the it's like backtracking. It's like looping. Yeah. So it's essentially going, you go from C, you go to C. That's how you literally explain it. Alright, so now we'll just implement that. Simply put, I'll just do a little linear search just to find out the values that are in the that are repeating or equal to. Alright, now let's quickly remove dual remove. Let's just say remove. We would put this thing with
his love for Jaina, something she always knew would keep
sorry.
She hopes that his spirit will find best free from that accursed place.
Source, destination, and of course we only need the source and destination again. It's very similar to the next one. Now we will remove that. Oh, remove has been taken. I will be careful with this. Remove node. Remove edge. Yeah. Let's just name it that. Remove edge. Remove edge. Now we go to the source and destination. Put in the source, put in the destination, and the source of Y and destination of Y. Now, how to identify duplicates, or rather returning nodes, nodes that recursively goes continues to go back to the source node. Well, there's no way. Actually, a simpler way is to not use the source and destination at all. We can just use this, remove this. I'm thinking of this as the fly, way, and on the fly, in source and in destination. Well, if essentially returning edge, right? If source equals to dest, then we return 0. Actually, we still need the source and destination array. Why? Because we want to see parallel edges. And since this is C, it's not much objective stuff you can do in objective oriented stuff that you can do in here. DST. Let's put it in over the, where is it? Damn it. Where is it? Where is it? Ah, there it is. Source. That, oh, I will mute this. I forgot. Oh no. Destination. I assume it was a TV. I'm sorry, Noble. So source and destination Okay, source and destination, we put it in here, source DST. We want to remove nodes that are parallel. Well, how do we do that? Well, let's just iterate on the constant size. It's always 6, right? The maximum size is always 6. It can be altered to have a dynamic size, but you know that's a lot of work. But I'm just showing here. I'm just showing how it works essentially. We can just use a linear search like this. If source and destination, right? Essentially, you want to put in like that. You search it if source I equals to source. Not be careful. This is not the disjoint that you're looking for. Let's just directly say and destination DST equals I equals to dest. We return 0 as well. Return 0 means false. Return 1 means true. Now what do we do with after that? What do we use this function for? Well, this function is to identify whether or not there are if every edge that is inputted has been it's not a duplicate, it's a duplicate. So now we can just call it this function equals to 0. We will change the source and destination into 0. Actually, -1 might be a better idea. And then weight is -1. So in this way we can differentiate it. In here we can just call one of them if, so we skip the ones that are not, if source E equals to -1. We skip the whole process of the sorting process. This should be enough. This is a very clunky implementation because source destination weight should be compared to each of them, but this is like the most simplest way it works. It should still work the same. Oh, I'm sorry, I think I made a mistake over here. It says that source was not declared. Let's go. Yeah, oh right, I must let's just do that. Big S, big S there. Right, 1 2 4 1 2 5. Now this should be 1 2 5 should be removed, and 1 2 4 should be removed. It depends actually. Yeah, 1 2 4 should be removed. 1 2 3 no 2 3 4 1 3 4 1 1 2 2, let's say 2 4 2. I think I made a bit of a mistake. What did I input in over there? Is equals to 0, right? And move edge. Oh wait, is that a double iteration? Oh no. Dios mío. Darn it, I have to copy that again. Do I have the previous one? Oh awesome, I have the previous one. Still, huh? Okay, that's a bit weird. Okay, again, let's analyze the issue here. Source destination I, source I -1, destination I -1, and weight I is -1 again. Source I equals to dest, and it's 0. This is essentially means that, okay, no, if it's 1 to 1, we cannot have that. We're going to just return 0 on it. For E, if source, and then there's the E summoning on this. Since it is looking for sets that what's called 2 to 3, 2 to 2, and 2 to 3. Source. Of course it will be the same, but what I want. So that's not the way. Of course it will. This is the cause. You know why? Because it's such a foolish move. Let's try that again. So instead of source, let's go. So now we need to note each source. We need to note each source that has been marked. We prepare an array of 6, I think. Yeah. Array of 6. Array of 6. What does this array of 6 do? Well, essentially, we need to compare it with the source and destination of, like, whether or not it has duplicates. Whether or not it has duplicates. How do we do that? Well, we're gonna do it right here, I think. So 2, 2, 3. How do we detect 2, 3 and then 2, 3 again? Well, when we put it 2 and 3 here, 2 and 3, 2 and 3 is in the database already. Is it in the what's called in the graph already? I know. This. So first I'll just Control Z this and then add the duplicate. What does duplicate does? Essentially, what it does, it's like you. What? Okay, there we go. Let's add something else. It's called duplicate. Goes to 0. Now, what does duplicate do? What duplicate does is that you add you duplicate. I'm sorry, what am I doing? What duplicate does is that it allows you to check for duplicates, like the straightforward, right? So now we just add something like and duplicate is more than 0. Actually, let's do this. If duplicate and turn equal more than 0, we return it. That means it's an actual duplicate. Return 0. Otherwise, otherwise continue. But increment duplicate. This should fix it, I think. Wait. Source was not the where's the previous one? As you can see, 1 to 4 is deemed as a duplicate. Why? Because there's 1 to 5. There's like 1 to 5. I mean, you can just, the computer chooses like based on appearance order. So 1 to 4 would be removed. No, 1 to 5 would be kept. It depends really on how you do it. You perform it. 1 to 5, and then what's else a duplicate? So this is like a duplicate. This is the minus ones are for duplicates. So as you can see, 1 1 1 1 1 1. I guess we could just it should be correct because first is a duplicate, and there are no non-unique nodes here. This is literally unique nodes: 2, 4, 1, 3, and then 1, 2. These are unique nodes. If it's unique and doesn't have any looping indications and doesn't have a duplicate, the Kruskal should be a good enough Kruskal for you. These -1s, they haven't been replaced. I think somehow they still linger over there. Even though I checked that. Okay, don't sort them. Don't sort them. I'll indicate -1. There it is. I think we shouldn't do it here. Maybe we should have done it over there. That should do it properly. That should finish it properly. Essentially, it indicates whether or not the source, there are duplicates in there. Prevent from doing duplicates. Oh crap! It's still doing it. Why? Why is it still doing it? It's correct. I think it should be correct, but it's like it disappears. Somehow for the second one is for 1 is 0. This doesn't really need double iterations because it's the same thing over and over again. 1 1 1. Why is the 1 1 1 sucks? This is already corrected. But I'm an OCD, so why is this 1 1 1 still lingers? Why is the first one still there? Source is not equals to -1. Wait. Okay. Printf. Let's debug here. This is debugging again. Debugging stage already. The algorithm is finished, but it's just that I want to debug this. Is there? I forgot how to delete arrays in here. In PHP you can use del. In Python actually. In PHP you can use unset, but malloc real no. I kinda forgot how to remove arrays in. You can just do it -1 -1 -1. Someone only wants to do one thing. I guess to be safe, we can override the weight again. Or not, no. No. Or to be much more to be better, we can just point to the index. I think that would do. Yeah, we can just we can remove we can point to the index instead of changing the value. We can point to the index of 6. Index I equals minus 1. If index I equals to minus 1, continue. I do not know. It's easy. Python and PHP you can just use like PHP. I think you can use delete or something. I think there's a key for that. Yeah, there's delete, but in C it's just like memory manipulation. So much complexity and stuff. But C is a good language to start with if you want to learn it. If you want to learn how to program. So yeah, we don't print anything that's indexed. Where's the part where I use? There it is. So if index is minus 1, continue. Okay, my bad. Oopsie. Copy that. Let's just copy paste this to everything. Oh god. And that should be it, I think. As you can see, the values that are compared are unique. There are values that are removed are this thing. As you can see here, this is like the sorted array, but yeah, it's not included. If I wanna go like further, I can just do this, because why is it it's not included? Because we only sort those who are not, who is not like, who is unique, who is valid to become a spanning tree, a part of the spanning tree. There. And I guess that's it for now. Let me know your questions and I'll be answering them, because I'm really active at YouTube. Well, alright. Bye.